So what is the difference with geometric series? That sentence is very similar to the one I wrote for arithmetic. I've just changed a couple of words. It's now geometric rather than arithmetic. Instead of adding a constant, we now multiply a constant. So geometric, we multiply. And that is called a common ratio, the amount we multiply by. And we give it the pirate's letter, R. So if we want to work out that common ratio, again, we could get any term divided by the one before. So term 2 divided by the first term, term 3 divided by the second term. I could pick any term divided by the one before. Again, I don't need consecutive terms to do it. The only problem I've got is if the two terms are an even number apart, I'm going to end up with an equation. Well, let's say they're just 2 apart. So say I've got the 5th term and the 7th term. And I go term 7 divided by term 5. I'm going to end up with r squared. Well, of course, r squared has 2 answers. It has plus or minus. So unless I have more information, I'd have to say, well, there's actually 2 possibilities for this pattern. It might go plus, minus, plus, minus, plus, minus, or it might go, the sign just stays the same. Just got to read the question carefully to see what sort of information that they've given us. So let's come up with a formula. First term is a, second term AR, third term AR squared. I'll multiply it by R again. Again, we can see a pattern emerging. So the nth term is AR to the n minus 1. So here's our pattern, 2, 8, 32. We're going to find R and the general term. So now, all the information I have is that, well, A is 2. By inspection, I can see that ratio is going to be 4. I'm multiplying by 4 each time. So I know what A is. I know what R is. It's general term, AR to the n minus 1. So 2 times 4 to the power of n minus 1. Now, that works. That's a fine formula. In fact, that's a formula that a mere mortal would use. But us super mathematicians would look at that. I can do better. I can do better. If you notice that the base of 4 and the number out the front here has a base of 2, but I could rewrite 4 so it's the same base. So I could say 4 is 2 squared, and I can come up with a much neater pattern now. Because 2 squared to the power of n minus 1, that becomes 2 to the power of 2n minus 2. Now multiply with the 2, so we add the powers, and I get a general term, a nice neat one there, of just 2 to the power of 2n minus 1. All right, the second term this is what I was talking about. Second term is 7, fourth term is 49, so AR is 7, AR cubed is 49, I end up with R squared is 7. So the ratio, there's 2 possibilities. It could be plus the square root of 7 or it could be minus the square root of 7. And with the information that's been given to me, there's no way I can determine which one it is. So I write both possibilities down. It could be plus or minus the square root of 7. So 1, 4, 16. Once again, which one will be the first one greater than 500? It's the same idea. Let's come up with a general term. First term is 1. The ratio is common of 4. So I get 1 times 4 to the power of n minus 1. That one's a lot easier to simplify, of course, because 1 times anything is itself. So when is that greater than 500? 4 to the power of something is greater than 500. Well, you could use trial and error here. Substitute numbers in. Or if you remember about logs. Well, that one, whenever you have exponential equations and so on, you log both sides. Well, what's involved with logging both sides? I simply write down the word log on both sides. There we go. But what that allows me to do, you may or may not remember, we have a log law that says that power I can bring to the front of the log. And so I get n minus 1 lots of log 4 is greater than log 500. Divide by the log 4, and I get n minus 1 is greater than 4.48. So n's bigger than 5.48. Be careful when using logs. The log of a number smaller than 1. So log of something between 0 and 1. Might be log of a half. Log of it is a negative number. So if we're dealing with inequalities, divide by a log of a number smaller than 1, got to change the inequality sign because you're actually dividing by a negative number. So term 6, which is 1024. All right, there we go. Let's add 6e. Time to play.